Hello guys, this time we're gonna talk about noble gas notation. This is the third method that we're gonna use to express or to show up the electron configuration of any element. Now let's start with an example. The instruction is build the electron configuration notation and the noble gas notation of the following elements. The first one is phosphorus, which is number 15. So first of all, we're going to start writing the electron configuration notation from this point over here, and we say 1s2, 2s2, 2p6. Here we have 10. We continue 3s2 and 3p3. So let me just be sure that I counted correctly. I have 6 and 6 is 12 and 3 15. So this is the electron configuration full notation of phosphorus. Now what if I want to express the same by using just the noble gas notation? So take a look. Here I have a list of the noble gases from our periodic table: helium, neon, argon, krypton, xenon, and radon. Here as a short exponent, as an exponent I wrote the atomic number. In this case, helium has only 2 electrons because it's number 2. And for example, argon has 18. And all these elements, except for helium, they accomplish the octet rule. That means that they have 8 electrons in the outermost level. That's why they don't react with other elements. Now, the idea of using noble gas notation is just another way to express the electron configuration. So we're going to take our phosphorus, which is number 15, and we're going to look for the noble gas that is before phosphorus. So phosphorus is in the middle of neon, which is 10, and argon, which is 18. So we're going to use the element that is before phosphorus, that is neon. So we say the noble gas notation will be neon 10. So how many electrons I am missing to get phosphorus? I'm missing 5 electrons. Those 5 electrons are the same 5 electrons that I have in my last steps that I did when I was building my full notation. So what I'm gonna do is I will just complete the noble gas notation with the 5 remaining elements: 3s2 and 3p3. So if you see in your periodic table, that will be your homework. Check in your periodic table that in the bottom of phosphorus you're gonna have the same: neon 3s2, 3p3. Okay, so that will be your homework. Check that everything that we do here is correct. So remember, this is the electron configuration notation, and this is the noble gas notation. Let's do more examples for selenium and bromine. As you can see, those elements are very close, 34 and 35. They are next to each other in the periodic table. So first of all, we're going to build the electron configuration of selenium. In this case, the electron configuration of selenium will be 1s2. I can do it in a single line, and this is exactly what I'm going to do today. 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. I have 30 so far, so I need 4 more. So after 3d10 it comes 4p6, but I'm not going to use 6 because I just need 34. So this will be 4p4. Now let's make sure that we did it correctly. 2, 2, and 6 is 10. 2, 2 and 6 is 10, and 10 is 30, and 4 is 34. So we did right. Now, we're going to look for the element that is right before selenium, not the closer, the one that is before. So selenium will be between argon and krypton right here. Okay? Yes, closer to krypton than argon, but the one that we're going to use is the one before, that is argon. So, the noble gas notation will be argon 18. Now, how many electrons I need to have 34? So, will be 34 minus 18. I need 16 electrons. Now, if you take a look here, we're going to do a backward process, and we're going to count 16 electrons, as we have here. 4 and 10, 14 and 2, 16. Those are the exact electrons that I need to complete my noble gas notation. There you go. Now if I ask you how many electrons do I have in the outermost level, will be the highest level is 4. So how many electrons I have in those levels? I have 4 and 2. There you go. Now let's do the same for bromine. Let's build the electron configuration notation of bromine. It will be similar to selenium. So let's follow the tree, and we say, now we're going to do it like a tree. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. I know I have 30 here, so I need 5 more, so it's going to be 4p5. Now, the noble gas, that's it, the electron configuration is full. But for the noble gas notation, I need my noble gas before bromine. That in this case, bromine is between argon and krypton, so I'm going to use argon, the one before, not the closer. Argon 18. So how many electrons I need to have 34? I say 35, which is bromine's number, minus 18 of argon, I need 17. And if you take a look, 17 are the last 3 sublevels that I brought over here. 3d10, 4p5, and 4s2. And if I wonder now how many electrons I have in the outermost level, I know that my outermost level is 4, so I have 2 and 5. I have 7 electrons in the outermost level. Let's do one more example. In this case, osmium, which is it has a greater number, which is 76. The electron configuration notation is going to be 1s2, 2s2, 2p6. Remember, we're following the tree. 3s2, 3p6, 4s2, 3d10. I have 30 now. After 3d10, it comes 4p6. So what I do is I place a mark to indicate that I have 30 here. Okay. Now 4p6, 5s2, 4d10. I have 48 now. Okay. After 4d10, I have 5p6. After 5p6, I have 6x2. After, I have 4f14. So I have 48 and 8 is 56 and 14 is 70, so that means that I need 6. So here I'm going to take from 10, I'm going to take just 6, and now I finish. Okay, now I can erase the marks that I placed before because it's a little bit annoying. Now this is the full configuration for osmium. Now I'm gonna take the noble gas notation, and the noble gas that is before osmium will be between xenon and radium. Okay, so we're gonna use xenon 54. Now how many electrons I need to get 76? 76 minus 54, I need 22 electrons. So I'm going to start counting from the back. So if you realize, I have 14 and 6, 20 and 2, 22. These are my 22 electrons. So it will be 4 F14, 5 D6, and 6 S2. This will be my noble gas notation for osmium. Now, is there another way to do it? Well, yes, and this is the way I prefer to do it, and it's like this. I build the electron configuration notation in a single line, as I'm going to do right now. Okay, so far I know I have 30. Okay, now I continue. After 3D10 it comes 4P6, 5S2, 4D10, 5P6, 6S2. Until here I have 30, 38, 48, and 8. I have 56. To get 76, that means that I still need 20. So I continue here for F14 and 5D. Okay, to get 20, I need 6. Like that. Now, as I'm going to use noble gas notation, remember this is another way to do it. As I'm gonna use my noble gas notation, I will search for the noble gas that is before osmium. So that is xenon 54. Now how many electrons I need for xenon to become osmium? For example, I need 22. So I have this 20 plus 2, 22. So I'm going to write all of them. You can write it the way it looks, or as I prefer to do it, I do it in order. 4F14, 5D6, and then 6S2. This is just another way to do it, and as you can see, we have the same answers. And this process, by doing a single line, it's a little bit more messy in my opinion, but it's better to visualize the electrons that you need to complete the noble gas notation. Bye guys, that's it.